Hello friends, this video on differential equation part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 and part 2. Now we have understood what is degree in order. Let's find the general and particular solution of a differential equation. So let's compare the differential equations with the normal equations we have. So the normal equation we are aware of this kind of equation which solves such an equation. X square minus 1 is equal to 0, then we say x is equal to 1 or minus 1, right? Or we say x plus 2 is equal to 0, you get x is equal to minus 2. These kind of equations we know where you have one or two solutions. They are always particular solution because it all depends on the power of this. So if it has 2 power, it will have at the max 2 solutions. If it has 1 power, it will have at the max 1 solution. These kind of equations we know. And the value of the x is always numbers. Please note, here I am getting x as 1 or minus 1, right? In this case I am getting x equal to minus 2. So value of x is always number. But the differential equation, as I told, is of this type. As I told, dy by dx plus kx, ky, kx equal to 0. This kind of form, correct? Now, in this case, the value of y I get is function. Please note, in this case, the value of x you get is number. The value which you get is number. In this case, I get functions. Now, since it is a function, it has two types of solution. It can be either a general solution or a particular solution. Example, in this case, I'll take, if I get dy by dx is equal to minus sin x, or I get dy is equal to minus sin x dx. I'll just solve this with the crude method without even using the steps. Integrate both sides, what I get, y is equal to cos x plus constant. So if you see, this guy is a general solution because my constant value c is not known. I can put the value of constant as 1, 2, 3, 4, 5. Then this guy is a general solution. But if I put the value of constant, for example, if I know the value of this curve, I know some y or x value, I can put this value, for example, y is equal to 0 when cos equal to pi by 2, something of that sort, but then I get the value of c also. And let's suppose c came out to be 8. Then I'll write my solution has to be y is equal to cos x plus 8. So in this case, if you see, I got a particular solution because I know this is the solution, right? Only one solution. But in this case, I am telling y is equal to cos x plus c, where c is any variable. So there can be multiple solutions with some value of c. Right? So such solution is a general solution where you have some variables defined and you say, okay, this variable can have any value, and thus you can have multiple solutions. That is the general solution. But when you have the actual value of that, then this is only one solution that becomes a particular solution. So the reason why we have this slide was to tell you two things. One is the solution for differential equation is not number, it's a function always. Second thing, the solution are of two types, either general or particular. So having said this, let's take some example to find solution of differential equation by the crude way. So in this case, we are doing a reverse way since we don't know yet how to solve the differential equation, but we can verify whether that particular solution is part of differential equation or not. So what I'm doing is we have to verify that this particular y is equal to e to the power x is my solution. This is function actually, and this is a particular solution, right? This fits this differential equation or not. So if I have my differential equation, I have my solution given, I have to check whether this particular solution is for this differential equation or not. For this, I need not know how to solve the differential equation, correct? So we have to verify that this given solution is fitting to this corresponding differential equation. So differential equation is y double dash minus y dash is equal to 0. So I have to find y double dash, I have to find y dash. So let's find y double dash. Or I have to find y dash also, let's find y dash first, then we'll find y double dash. So if my y is equal to e to the power x plus 1, my y dash will be e to the power x plus 0. And y double dash will be e to the power x plus 0 itself. Correct? Why? Because my y is equal to e to the power x plus 1. You differentiate this guy, e to the power x become e to the power x itself. 1 becomes 0. Here also 0 becomes 0 only. So that's how I get y dash and y double dash. So my differential equation is this. So let's put the value of this guy. Y double dash is e to the power x plus 0 is 0 only. And y dash is also same. So if you see, this guy becomes 0. So this actually fits to this solution. But I can say that this solution is a solution for this differential equation. Correct? So I don't know yet how to find the solution for differential equation, but now what I have done is given a solution of the differential equation, I verified whether that solution is correct or not. Let's take one example. Y is equal to cos x plus c. This is, if you see, is a general solution. Please note, it is not a general solution, it is a general solution because it's constant term here. And this is my differential equation. I have to verify if this solution is for this equation. So this equation needs y dash. Let's find y dash. Y dash becomes minus sin x. C becomes x. This is my y dash. So my equation says y dash plus sin x is equal to 0. What is y dash? Minus sin x. Correct? Plus sin x. And that is true actually. Since this is true, I can say that this particular solution is true for this differential equation. Let's take one more example, little different here. So this is my solution here, right? This is my solution. And this is my differential equation. I have to prove whether this solution is true for this equation. For this I have to find y dash. That's all I have to find. So let's find y dash. Y dash becomes, to differentiate x, this becomes 1 into sin x plus, you take this guy common, x, differentiate sin x, this becomes cos x. So this becomes sin x plus x cos x. This is my y dash. I've used the product rule actually. Differentiate this guy, keep this guy constant, keep this guy constant, differentiate this guy. So I got y dash. Now I have to check whether this guy fits in this. So my equation is x, y dash is this guy, sin x plus x cos x is equal to y is again x sin x. I'm putting everything in terms of x plus x into root of x square minus y square. Y square is nothing but x square sin square x. Correct? So I have to prove if LHS is equal to RHS. Correct? So this is my LHS and this is my RHS. So I'll take RHS, I'll expand more RHS. This becomes x sin x plus x into 1 minus sin square x. Correct? And 1 minus sin square x is cos square x. So this becomes x sin x plus x into root of x square cos square x. And this becomes nothing but x sin x plus x square cos x. And if you see, this guy is exactly same as my LHS. If you take x common, so this becomes. So if you see, this guy is equal to LHS itself. So I can prove that my LHS is equal to RHS. That means this is true. Correct? So these kind of questions are not that difficult. You have the solution given, you have the equation given. You just have to put that solution in this equation. So I did that. I put y is equal to x sin x and y dash I was to find. So I found y dash from this equation only. I got y dash equal to x sin x plus s cos x. So I put y dash equal to sin x plus s cos x, right? And I've checked whether this was equal, LHS and RHS. Let's take one more example. Y is equal to root of 1 plus x square is my solution for this differential equation y dash is equal to xy by 1 plus x square. Correct. To find that, first I have to find y dash also, because this implies y and y dash. So let's find y dash. So y dash is nothing but, this is to the power 1 by 2, so this becomes 1 by 2 into 1 plus x squared to the power minus 1 by 2, and x square becomes 2x. Correct. So this becomes 2 and 2 cancel, this becomes x by root 1 plus x square. Correct. And this is my LHS if you see. Let's find the RHS. xy by 1 plus x square. This guy is nothing but x, y is nothing but root 1 plus x square by 1 plus x square. If you cut this, this becomes x by root 1 plus x square. Why? Because this guy is nothing but root 1 plus x square to the power 2. And this guy, if you see, is nothing but my LHS. Thus I have proved that RHS is equal to LHS. If RHS is equal to LHS, that means this particular function is a solution for this equation. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.